Hi, Calc class. I guess this is sort of a welcome back. Not exactly, but as close as we're going to get right now. Um, this isn't a lecture out of the book. This is, I kind of want to get a head start on kind of how this is going to work. So over the next weeks, my plan is to make videos like this to go with lectures. Maybe not all of them, but quite a few of them I'd like to make, kind of just cover them like we covered them in class. I will also be emailing out office hours. Those would be times that you can email me anytime during the day, but those would be times when you could call the school, or I'll be watching my email a little more attentively. But I'm also going to set up a meets. It'll be in your calendar, so that if you want to talk to me through the webcams, or we can actually do chats. Something's going to show up on all of your calendars that you'll just click on my office hours. I plan on doing 1 to 2 hours every day. I haven't actually set up what I want to do for my calendar yet, but I'll be doing office hours 1 or 2 evenings as well, like maybe from like 5 to 6 or something like that for those that maybe need a little bit later time. But we'll be going through Moodle. I'll post these videos in Moodle, and you should have those codes for now. I'll probably email out the code again. I think most of you have used it by now, but just in case. You, of course, have my notes. You'll have other links. I've got some other videos I've been trying to find off of YouTube where people have some really nice animations, things I don't know how to do, to maybe help you understand some of these concepts, since we can't talk like we would normally talk. But I'm giving this a try, and I thought, well, to start off as I'm trying, let's look at something that's obviously current news, something we're all thinking about. That'd be, of course, the coronavirus. And I found this quote out of the Washington Post a few days ago. They were actually asking the question, is this an exponential growth? They said, why outbreaks like coronavirus spread exponentially? And of course, the topic is how to flatten the curve, and I'll talk about both of them a little bit, and a little bit about how, with calculus, we can maybe understand part of the decision-making process the government's having to go through right now. You'll see when we're done. I can't get through all of that, but some of it. So, to start off with, I thought we would look at the question of it being exponential or not, because the Washington Post, they were saying it, but they were kind of asking it. If you read the article, they were kind of going off an assumption, but a lot of people don't really know what it means to be exponential. As far as flattening the curve, the reason they're talking about flattening the curve, I'm sure a lot of you know this already, but it's the idea of, do you want everybody to get it at once, or spread it out? If everybody gets it at once, there's this amount where our hospitals and clinics just can't handle anymore. China at one point, we know, had to just send people home, in some cases send people home to die. We're trying to avoid that here in the United States, so we're trying to flatten out this bell curve, squish it down. Now that has ramifications. If you look at this picture here, if you squish it down, the amount of time it takes to get through the curve, of course, is going to take longer. So that's the give and the take. But the idea is, if we could squish it down, not overwhelm our medical facilities, well, then, of course, we should be, in theory, be able to save lives. I put this picture over here of these matches. That's kind of the idea of, do you want it all going off at once, or do you want to spread out? Social distancing, you want to spread out, and the people that are going to get it are probably still going to get it. It's just a matter of not all at the same time. So the idea for the government is that if we can flatten it, we should be able to save lives, because then our medical facilities can do what they're supposed to do. As far as the question, is it exponential? I've been tracking some data. As I know, I'm the math nerd. I've been tracking some data here from the CDC for a few days. And I know I'm a few days behind on this. When I started this presentation last Friday. As of last Friday, there were 13,474 cases in the United States. Today is Monday. I know it's over 30. I looked it up, and you're going to see here in just a second that this is going through a doubling process, real close to it. So the question, is it exponential? Well, if it was linear, it would be changing at the same rate day after day, which obviously it's not doing that. Or it would be adding, let's see here, in the first day, it would have gone from 15 to 29, and then 29 to 35, 35 to 38. That was a slow day, I guess. It's not changing by the same, not even close. And of course, as the numbers got bigger, then they started to really take off. So no, it's not linear. Is it quadratic? No, it's not quadratic, because it'd be things that are squaring. From 15, you'd go to 225, and then you'd square the 225, and so on and so forth. So it's not quadratic. Is it exponential? To answer the question, is it exponential, you really have to answer the question, is something multiplying by itself over and over again? So I did a little analysis here. All I'm doing is I took the ratio of the previous day and divided it into the next day. So 29 divided by 15, I divided that. And then 35 divided by 29. I went through all the days, and then I averaged it out. On average, it's being multiplied by about 1.2. So 1.2 again and again and again and again, which, yes, that would mean it's exponential. From that, we could even write an equation. This looks kind of like the PERT equation, except instead of E, I would just be using 1.2 as my base, starting off with 15. What did I start with? What did I end with? What am I multiplying by over and over again? The Washington Post was claiming doubling every 3 days, so I thought I would look at that. And actually, they're almost right on. If you look at a ratio of, so from every third day, you come up with these numbers here. Again, I was just dividing, and when I averaged them out, yep, it's averaging out to be just over 2 every third day. So of course we could use that model, starting with 15 and doubling every third day would give us an exponential model. I'm going to come back to this later. Is it exponential? In fact, I think I'm going to cover it right now. Is it exponential? Well, sort of, for now. And that's going to lead us to a calculus question. When does it become not exponential? And what I mean by that is we know it should eventually start to slow down. You guys remember from pre-calc, we talked about the Gaussian curve, also called the normal curve, also called the bell curve. And it had a big, nasty equation. I'm not going to get into that with you guys. But it had to do with what was the average amount. And of course, we ended up with a bell curve. We are in this exponential growth portion down here. Eventually, the rate of change is going to start slowing down. At the top here, this we should know as calc students. The top here, the rate of change is 0. It's growing right now, but it's going to start slowing down eventually because we know it goes to 0, and then it goes in the opposite direction, a negative rate of change that will eventually accelerate, but then of course it will slow down. One of the next calc topics we're going to cover here, and I think I have that next, yes, is that question. When does it start to slow down? It has to do with when the tangent lines go from being underneath to being above the curve. Somewhere right about here on this curve is a spot. It's called an inflection point. And you're going to look at what's called the second derivative test. It's coming up 2 lessons from now. The second derivative test helps us figure out that spot. Where does it switch from exponentially growing to starting to exponentially decay? This is actually turning into an exponential decay is what it is. And then of course it's flat for a second, for a short period of time. And then everything gets reversed. Where does that start? And of course that would be the question. And I'll be honest, I can't answer that right now because there's so many variables in this situation. It's a guess. But I'll go through a calculation with you, assuming it was exponential. Best case scenario would be it would stay exponential because it would get through the population the fastest. I'm going to go through a calculation for you. And again, this would be, I guess, as far as getting back to school or getting back to normal in life, the best case situation. Not the best case for the hospitals. So this is not what we actually want. But as far as I know, a lot of you guys are thinking about, when do I get to start living my life normal again? In that case, we could look at it from an exponential point of view as an approximation. It's a bad approximation, but I can still go through it with you. Some facts. Right now, on average, the numbers we're getting from China is an infection rate of about 40%. At least that's the initial infection rate. Will it eventually hit the whole population? I don't know. I saw an interview with a lady from the CDC that says yes, but I don't know. The population in the US right now, coast to coast, plus Alaska and Hawaii, is 327 some million people, a lot of people. So I found 40% of that. Okay, so if only 40% get infected, then we'd be looking at 130,800,000-ish people getting infected. Half of that, because we're only going halfway up the bell curve. So to figure out, well, when would we get to the top? Is actually, that's all it would do. When would we get to the top if it was exponential? Well, then I would take half of that to get, up here to the top of the bell curve. 6,540,000. I could go through all of them, but I figure this is kind of an average way of doing it, since I'll be using an exponential function to approximate a normal curve. So I thought, well, I'll just go to the halfway marker. That's why I did that. So I took my equation. I took the doubling one. So just every third day, again, starting at 15 people, doubling, so 2.1 every third day. When is that going to be equal to the 6,540,000? Of course, we have to use logarithms to solve that. So I'll take we're actually going to do the change of base formula is what I'm going to do here. Take log of each side. Sorry, I did have to divide by 15 first. Got that base and exponent by themselves. Take the log of each side and divide. And I ended up with pushing 21 times. Now remember, that's every 3 days. That's not days, it's every 3 days. So if you multiply by 3, it'd be about 62 days to get to the top of the bell curve. And that's if it was a continuous exponential growth. So it could be an approximation, because I know, we all know that it will start slowing down the rate of change as it approaches the top. As calc students, I love that I can talk to you guys about that. My other classes, if I talk about this, they're not going to understand that the way you would. But if I use the exponential approximation, 2 months, that would be halfway through. To get through the whole bubble, well, it'd be 4 months is what we'd be looking at here. Because of all of my approximating, sadly, I think it's going to be more than that. So like I've got here, the calculation would give us just over 2 months, but I have some assumptions here, and because of the assumptions, I know that my calculation is not going to be right. It's just going to be a very poor approximation, because my assumptions were it's going to stop at 40%. We don't know. That's what it was in China. Is everybody going to eventually get it? I don't know. Anybody knows the answer to that. They say over the next years, probably everybody will. Second assumption, that it stays exponential. Well, we know it's not exponential. I know it's a Gaussian curve, a bell curve. I was just using that to approximate. And the third thing, though, is, are we able to flatten it out? We're trying to flatten it out, which is the goal. Normal life would be awesome right now. I would agree with you, but we do need to try and flatten it out, because we know that that's going to save lives. So, not the happiest topic, but I thought, well, let's look at this situation from a calculus point of view. Thank you for watching this. I hope that as the rest of the semester goes on, we can still be productive, still learn things. And I hopefully will be talking to some of you, at least if nothing else, over the meets thing. So watch your calendars, watch your emails, and I'll talk to you later.